In this example, let's take a look at how we should consider the domain when combining functions through division. So to get started, we need a couple of functions. And for this example, we're going to use two functions that look like, at first glance, they'll work together very nicely, but they add an extra wrinkle into the domain problem that's going to be a little bit of an issue for us. So we're going to start with f of x, which is x squared minus 4, and g of x, which is x minus 2. And specifically, we're going to be interested in building the function g of x over f of x. When we consider the domain of a combination, specifically for division and specifically for polynomials, we want to consider the domain before we start doing any kind of simplifying. So very quickly, if I was just to build this function, x minus 2 over x squared minus 4, at first glance, knowing the algebra that you do, you might think that you'd be able to do this. We have a difference of squares in the denominator. Let's do a quick cancellation, and now I'm not going to have to worry about that factor. But unfortunately for us, in combining our functions, our domain work has to come from here. So even though that x minus 2 was simplified with the x minus 2 in the numerator, our statement of the function, g of x over f of x, requires that we take the domain from this version. So we need to look at the entirety of this denominator and say, well, x is not going to be allowed to be 2 or negative 2. Can't cancel out that 2 factor from, or excuse me, the 2 in making the denominator 0 from that x minus 2 factor. We're going to have to leave him in there as this consideration happens from the very beginning. So if I had to write my domain for g of x over f of x, my domain would say we're going to go all the way up to negative 2. Then we're going to go between negative 2 and 2. And you'll excuse me, I have to go to the next line to write this last part. And I'm going to go above 2. Negative 2 and negative 2 get the open interval because I'm not at either of those points. Same thing with 2, not included in the domain. We just have to be careful to do this from the very beginning, not try to wait until the end, not try to wait until we've simplified. And some work you've done with rational functions in the past might help support your understanding in this regard. It's the same idea. If we're thinking about things like vertical asymptotes and where a hole in a graph might be, those are extra considerations, and they definitely apply to the domain.